Hello, my dear lovely students. How are you? I hope you are quite well, happy, and your study is going very fine. Today, we are going to discuss the haloform reactions. In haloform, iodoform, and that is the chemical properties of aldehyde and ketones. So, let's start. Students, once you understand, please like, share, and subscribe the channel. If you have any doubt, I mention in every video lecture email ID. Please you go and send me any doubts regarding this video or regarding this any topic. I will mention your questions in the next video lecture. Okay, so let's start that. That is the students we understand here. Haloform, haloform reactions. So in haloform, what actually see students? So those compound which have a methyl ketone, either the methyl ketone. Student, haloform is what? CHX3. So CHX3 is that haloform. So either in haloform, the condition is that any compound would go under the haloform reactions. They must have the methyl ketone, or they have like that CH3 C double bond OH. Right? So those compound which will have at least the CH3 groups, one CH3 group or methyl ketone like that. So that will undergo the haloform reactions. Okay. So what I'm telling you, let's understand through that questions here, student. R C double bond OCH3. Okay. So if you have taken the X2 in the presence of base, you will get that R C double bond O X. Here is that. Uh, Here is that negative plus CHX3. You will get it. Okay. See, student, as you know that this point is the substances, the hydrogens, the carbon which are directly attached to the carbonyl group is the most acidic carbons. That means their hydrogen is most acidic hydrogens. Okay. So now one side should be the methyl group, second side should be anything. So this alk R may be hydrogens, maybe alkyl group, or maybe aryl group. Correct? This Re would be maybe hydrogens, alkyl, or aryl group. So one side should be that methyl, it must, and second side anything should be attached, anything would be attached there like that. Now the point is, what I said, we are taking that we are going to form the iodoform or bromoform, means haloform is a base promoted. So since we have taken the base, so it is called base promoted reactions, correct? Now the point is that how this base will work on this in the whole methyl ketone or like that methyl carbonyls, how it will work like that. Student, what I said that those carbon which are directly connected in the carbonyl group is the most acidic carbon. That means their hydrogen is most acidic hydrogens. So through the most acidic hydrogen, you will generate the enolate ions. How? See. So I write here, students, see that R C double bond O CH2H. Can I write like that? Yes, CH3. And you have a base OH minus. Student, base attack on the hydrogens, and what will happen? The compound will form like that. We have taken the base, okay, and then you will get that RC double bond O CH2 negative. Student, there will be resonance in the compound because it is enolate ions. So what will happen? RC double bond RC RCO, because the bond will shift towards the oxygen, negative charge will come and double bond will. So this is called enolate ions. Student, as you know, enolate ions is ambident nucleophile. So enolate ions, and it is a nucleophile. What if this is a nucleophiles? Okay. So or nucleophile. So now what will happen, students? Now and it is you can say that this is the first enolate ions. Okay. Now, students, this is the most acidic point. This is the most acidic. This is the most acidic hydrogens. Now, the halogens X the halogen will attack on the carbons, on the enolate ions. Okay, so how it will attack? It will attack like the SN2 fashion, means like SN2 fashions, right? It will attack to generate the halocarbonyls, means halogens attack on this carbon. Any, either you take this one enolate or you can take this enolate. So halogens attack on the enolate ions and generate the what? Halocarbonyls. How? See here, because one halogen contains partial delta positive, second is partial delta negative. Okay, so what is going to happen, students? That will form like R C. You can see here RC double bond O and CH2X will form. Correct? Because one X will attack here, and what will remove? X negative will remove. Understood? Understood? This is called halo carbonyl. Correct? Now you know one thing, students. Now earlier this is a highly acidic hydrogen. Now here the one halogen is attached along with the carbonyl. Carbon is also there. What do you think? Is this not a extremely highly acidic? Yes, it is extremely highly acidic carbon. Means now here is the two hydrogen, which is highly acidic hydrogen. What I am telling you now, first enolate is generated when the base OH minus attack on the protons on the acid. Then first enolate is generated. What do you think? Second generation of second enolate ion is much easier than the first enolate ion generation. Why? Because this hydrogen is highly acidic now. So what I am telling you is to first halogens. This is the first halogens. So first halogen makes the remaining alpha halogens, very easier, right? So, or you can say that the second generation of second enolate ion is very easier than the first enolate ion, and generation of third enolate ion is much easier than the first or second, because as you know, more halogen will attach along with the carbonyl group. This position will be more acidic, right? So now what happened again? We'll take the base OH minus. Now this base will attack on the hydrogens. So again water will remove, and R C double bond O CH negative X. This is called second enolate ions. It is second enolate ions. Correct? Now this second enolate ions, exactly what happened? Partial delta positive, partial delta negative. It will attack here, and now what is going to form? There is a R C double bond O C H X, and X will form. One X will remove. Again OH minus base will attack, hydrogen will remove, R C double bond O carbon X X, and X will form. Student, this is called, as you see here, have you seen there? Since that what happened? Since that here is negative charge is there, because of when base attack water is removed. So this is called third enolate ions. It is called third enolate ions. So generation of third enolate ion is very easier than the first or second enolate ions. Now students, when will what happen? Again X will take, X will remove, X negative, and the R C double bond O C X X, and X will form. This is called alpha 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 tri haloketone. What we can say? Alpha 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 tri haloketones. So students, this compound is generated. Now what will happen? Understand. See students, now addition eliminations will favor. Now what happen? Additions, eliminations will happen. See one. What I am telling you, suppose you have R C double bond O C X3, already we have done here. So when base will when the base attack on the carbon here, that will remove. Okay. So what is going to be happen? R C O negative CH3 and OH will. Student, you know, now CX3 will be the better leaving group. Okay, because leaving group depend on how their conjugate terms is going to be stable. Students, what do you think? When this CX3 will remove, what will happen? CX3 negative will form. Now, you know one thing. When the carbon connected with the halogen, that is more stable anions. It is a very, very stable anion. Now, once the CX3 will remove, that will come in the back and come back to that and form the carbonyl group like that. RC double bond O, OH will form. Okay, and plus you have plus CX3 negative. Now, this is a highly basic. It will attack on this proton, and what will generate here? That will generate R C double bond O negative plus CHX3. Have you seen that? How to obtain the CHX3? Did you see that? How to obtain the CH3 students? First, what happened? Again, please tell me what we have done first. First, we have generated the enolate ions. Student, once the enolate ion is generated, then the halogen attack on the enolate of carbon. Once the halogen attacks there, the compound is formed like that. Once the compound is formed, now this is the highly acidic. Simultaneously, same thing will happen. The OH will attack until and unless all hydrogen will not remove, attacks takes place. So then ultimately three enolate ions will form because you have three hydrogens in the carbons, three hydrogen attached with the carbon. Once you got these compounds, once you obtain this compound, now OH minus again will attack on the carbons, right? And then you will get the CHX, correct? Understood? So now my question to you, my question is, what do you think, students? CH3, C double bond O CH3 you have, okay? My question to you, what do you think? Cl2 and we have taken the aqueous NH, okay? Or we have taken that Br2 or aqueous NH, correct? And we have taken the I2 and aqueous K. What do you think? Here is the forming that CHCl3, here is the CHBr3, here is the CHIP. What do you think? The rate of formation is different? Will the rate of formation be different or not? Just you tell me. Think about it. No, student. The rate of formation of CHCl3 or CHBr3 or CHI3 will be totally same, absolutely same. Means the rate of formation of all these three are same because, student, one thing keep in mind, rate of haloform, is independent of concentration and identity of halogens, correct? So it does not depend on what halogen you have taken and what amount you have taken. So student, rate depends on the enolate ion because formation of enolate ions is a rate determining step. So keep in mind here, enolate formation is what? Is a rate determining steps. Understood, students? Enolate formation is RDS, rate determining step, correct? Now my next question to you, students, what do you think? Here is the CH3, CH2, C double bond, OCH3 is there, okay? And we have taken the first I2, aqueous NaOH. And second, we have taken the what? H3O plus. So why the base, why the OH attack on the methyl group, not a methylene? Can you tell me? Can you tell me why the OH will attack on the methyl positions, alpha position, not a methylene positions? Just to think about it, why it's happened? See, students, it is actually, earlier I said, it is a base promoted halogenation. What is this? It is the base promoted halogenation, okay? Not acid promoted. Acid, it is not a acid promoted. So halogenation Halogenation takes place at the less substituted alpha carbon. Understood? So that's the region, students. What I tell that the region is that the OH minus will attack on the less substituted, less hindered. This position is more hindered. It is less hindered. So base will attack on the less hindered positions like methyl groups. So I hope you understood the iodoform reactions or chloroform or fluoroform strengths. So you know one thing, strengths, CH3, CH OH CH3 will also give the iodoform reaction because ultimately it will oxidize and form the ketone like that. So you can say that your acetone, your 2-degree alcohol can give the iodoform reaction because it will convert into the acetone. And this compound, when we'll take that X2 plus NaOH, student, in the conversion manner, when you have to solve the conversion, you can write that 3 moles of NaOI if you have to obtain the iodoform. Or if you have to obtain the chloroform, you can write that. Means uh, suppose you have to go in the conversion, you simply write that. So don't write every time because you are writing like that. So you have to balance the reactions, or sometimes you will get in the trap in the byproduct like that. So if you write like that, it is also correct. Sodium hypoiodate, it is called sodium hypoiodate. So we can take like that, and directly you can get that CHI3 plus CH3 COON. So whatever compound you have like that C double bond OCH3, and here is whatever things will attach, that will undergoes into the iodoform reaction. Student, iodoform is a weak oxidizing agent. We have done that some weak oxidizing agent earlier in the carbonyl compound chemical test in the carbonyl in the aldehyde group like that Tollens, Fehling, Benedict, Sips. This is another weak oxidizing agent. So I hope you understood all these things. Thank you, students. Have a nice day. Take care.